Bringing you the IM341 Extra Practice number 6 solutions on solving quadratics using factoring. In this one, we've got a puzzle involving some geometric word problems, so let's go ahead and take a look at that. For this puzzle, this is a fairly straightforward one. The idea here is we have a bunch of word problems involving some geometric shapes. We have to solve those and figure out the answers in this answer column here, and then whatever word is next to that answer, we'll put that word next to the letter that goes with the problem up here. Nothing else fancy, just find each word one after the other as we go. So let's get down to it. All right, here we go with our opening problem, problem A. In this one, we have the length of a rectangle is 3 centimeters more than the width, and the area is 70 centimeters squared. We want the dimensions of the rectangle. Cool. Well, let's start with a formula. We're talking about the area of a rectangle. So I'm going to start with A equals L times W. And for this one, I'm going to start filling in different things based off of what they said in the problem. So they said the area is 70, so I can put 70 in for A. And they said the length is 3 more than the width. And I don't know what the width is. So for the width, I'm going to just keep W. And then the length I can express as W plus 3. So I'm going to write W plus 3, and then I just have normal W filling in for the width, playing itself in this motion picture, as it were. All right, so this is going to be a quadratic. So I'm going to go ahead and multiply this out, zero it out, get it in standard form, and then hopefully I can factor this thing. So distributing that W on the right side, I've got W squared plus 3 times W. And then let me just subtract that 70 to get it over there. So I'll have W squared plus 3W minus 70. And I'm going to write the equals 0 over on the right side just because I kind of twitch if it's on the left side. It's just who I am here. All right, so now that I've got a squared coefficient of just 1, and I've got it in standard form, I can just ask for factors of negative 70 that add up to 3. So let me think here. Factors of negative 70 that add up to 3. We've got 1 and 70. No way that's working. 2 and 35 doesn't work. 4 doesn't go into 70. 5 and 14 is getting closer, but still not what we need. 7 and 10 would work if we had negative 7 and positive 10. So let me break this up into W minus 7 and W plus 10. Now I have to go through and solve this by zeroing out each of those factors. So 7 minus 7 is 0, so that gives us one of our W values. And then negative 10 plus 10 would zero out this other one. Now we have to also think about kind of the real-life application of what's going on here. The W we just found is the width of some rectangle. 7 is okay. Negative 10 definitely not okay. We can't have negative dimensions. So I'm going to cross that off and not worry about it. So it's just 7 we're dealing with. And they wanted the dimensions of the rectangle, so we need the length as well. The length, remember, was W plus 3. So add 7 to 3, we've got 10. So 7 by 10 is what we're looking for, and this is in centimeters. Looking over in my answer column, we have 7 by 10 right here, so the is going to be our first word. Problem B is kind of similar in setup to problem A. Now we have the length of a rectangle is 4 more than the width. And then the area is 96. So really the same exact format. They just changed it to a 4 and a 96. So we'll start the same way. We've got our area formula for a rectangle, A equals LW. And then area this time is 96, so we can fill that in. Length, they said, is 4 more than the width. So I'll just write that as W plus 4. And then width itself, we can still represent as W. So let's put this in standard form. First, I'll distribute that W. That'll be W squared plus 4W. And then let me subtract that 96 to get it over on the other side. So there's going to be our standard zeroed out form. This time, I'm looking for factors of negative 96 that add up to 4. So I feel like this might be a little trickier than the last one. 1 and 96 doesn't work. 2 and 48 doesn't work. 3 goes into 96 32 times, still not going to work. 4 goes into that 24 times. We're getting closer, but still not really where we need to be. We also have 6 times 16, I believe. that's not going to work and get us a 4 anyway. So what else can I use? Well, let me think. 9, does 7 go into this? 7 does not. Does 8? 8, I think, goes into 96 12 times. Yeah, that actually would work. If I have negative 8 and positive 12. So W minus 8, W plus 12. And then zeroing each of these out, we get W equals positive 8, because 8 minus 8 is 0, and negative 12. Again, though, we can't have a negative dimension of a shape, so this negative 12 can just get thrown out. It doesn't work in this context. And we have 8 as the width. We just need to find the length now. That was W plus 4. So 8 plus 4 is going to give us 12 for the length. And then that gives us 8 by 12, which, looking over here on the right, we've got 8 by 12 here. Let's just make sure my units match up. They said centimeters squared. So yeah, we should have centimeters. So crooked then is going in box B. For this problem now, we have the length of a photograph, 1 centimeter less than twice the width. Area is 45 centimeters squared. We want the dimensions of the photograph this time around. All right, well, I can again start with area equals length times width. They never actually spelled out that this is a rectangle, but I think we can just assume, if they don't say otherwise, that we've got a photograph that's a rectangle. So now we've got area of 45. I can put that in for A. And they said the length was 1 less than twice the width. So twice the width would be 2 times W. 1 less than that would be 2W minus 1. So I've got 2W minus 1 for the L there. And then W again is just going to be itself in this one. All right, another quadratic. Let me multiply this out, zero it out, and see if I can factor it. So we have 2W squared minus 1W over there, if I distribute that W. And then subtract the 45 to get that over to the other side. Now I can't take out any common factors, so I'm going to go with AC method on this one. So 2 times negative 45, that's going to give me negative 90. And now I'm looking for factors of negative 90 that add up to, this is a negative 1 right here. So I can think of those kind of right away, because I think of 9 times 10, and if I had a positive 9 and a negative 10, that would add up to negative 1. So I'm going to write this as 2W squared plus 9W minus 10W minus 45. Now that I've got 4 terms, let me go ahead and do my grouping. So I can take out a W from the first 2 terms. That leaves me with 2W plus 9. For the next 2 terms, I can take out a negative 5, leaving me again with a 2W and a plus 5, or plus 9 rather. Okay, I've got 2W plus 9 as a common factor. I can take that out of everything. And then this W minus 5 is my leftovers going next to that. Setting each of these equal to 0 and solving. For this first one, it's a little tricky. I have to subtract 9 and divide by 2 to get negative 9 halves as that answer. And then W minus 5, that's going to be 5, because 5 minus 5 is 0. But now this negative 9 over 2, that's not going to work because we can't have a negative dimension, so let's cross that off. And it's just 5 we're worried about. Now they told us that the length was 2 times this minus 1. So 2 times 5 minus 1, that's 10 minus 1, gives us a length of 9, and that's 9 centimeters. So 5 centimeters by 9 centimeters, and that's at the very bottom of this list here. That's going to be furniture. So we've got furniture for C. This one, we have the sides of a square being increased by 3 meters, and the area then becomes 64 meters squared. We want the length of the side of the original square. So I'll set up an area formula for this based off of a square. That would be area equals S squared, side squared. And now they told me that the new area is 64, so I'll put that in. And that's only true if I increase the sides of the square by 3 meters. So this S, I'm going to write that now as S plus 3 quantity squared. And that should equal 64. So this is the original side increased by 3. At this point, I just have to multiply this out and put it in standard form and factor it again. So I'm going to use my shortcut for these squared binomials. Square the first thing, multiply these together and double it, and then square the last thing. So squaring the first thing gives me s squared. Multiplying these and doubling it gives me 2 times 3s, which is 6s, so plus 6s. And then 3 squared gives me 9. Let me just subtract the 64 to get this in standard form. 9 minus 64, I believe that's negative 55. And since I just have a squared coefficient of 1, I can find factors of negative 55 that add up to 6. Well, let me think. 1 and 55 definitely doesn't work. Let's see, 3 doesn't go into that. 5 goes into it for sure, 5 and 11. I can definitely get a 6 out of that if I have negative 5 and positive 11. So let me split this up into s minus 5, s plus 11 equals 0. Zeroing each of these out, I get s equals positive 5 and negative 11. And I can't have a negative dimension, so let me cross off the negative 11. And then I just needed one side of the square because they're all the same. So 5 meters in this case, that's the units. 5 meters is what we're looking for over here. And I see that kind of toward the middle next to dealer, so D for dealer. This next one is a little bit trickier as far as square problems go. So we have a square field that has 5 meters added to its length and 2 meters added to its width. So that changes things because this is no longer a square at that point if we do this unevenly. Then the field had an area of 130 meters squared. We want the length of a side of the original field. Okay, so I've got my starting formula, A equals S squared, but I'm also going to write A equals LW because I have both a square and a rectangle kind of situation going on here. When I write out my equation, I'm actually going to have to use this LW formula because we're doing different things to the length and the width to get the new area. So my new area is 130. That goes in for A, whichever version of this you're using. And then they said that the length had 5 meters added to it. So instead of writing L, I'm going to write S plus 5 because that was the original side with 5 added. And then they said the width had 2 meters added, so I'm going to write S plus 2 instead of W. Now that I've got everything in terms of S, when I solve this whole thing, I'm going to end up getting the side of the original square. So that's kind of nice how I've got this set up. But now I have to actually multiply this out and get everything in standard form. So the 130 can stay where it is. And then just foiling this out, we have S times S is S squared. S times 2 is 2S. 5 times S is a plus 5S. And then 5 times 2 gives me plus 10. The S squared can stay where it is. I'm going to add these S's together to get a 7S. And then I'm going to subtract 130 to get that over to the other side there, so I can zero this out. 10 minus 130 is negative 120. Now I'm looking for factors of negative 120 that add up to 7. 1 and 120 doesn't work. 2 and 60, no. 3 and 40, 4 and 30, none of these are working. 5 and 24, closer but still not working. 6 and 20. That would get me 14, still not what I need. All right, what else can I do? Let's see, I've got, does 7 go into that? I don't think it does. 8, I think 8 goes into this 15 times. So if I have negative 8 and positive 15, I can get positive 7. So let me split this up then into, we'll have S plus, or minus rather, S minus 8 and S plus 15. Zeroing each of these out, I get S equals positive 8 now as one of my S values, and also negative 15 for that other parentheses. But here again, we can't have negative dimensions, so cross out the negative. And then 8 meters is what we're looking for, and that's over here next to who. So let's put that in the E block. For this F problem, dimensions of a rectangular garden were 4 by 5. So they're giving us the original dimensions, and then each dimension is increased by the same amount. And then the garden had an area of 56 meters squared. We want the dimensions of the new garden. And they even gave us a hint, let X be the amount of increase. All right, so we're dealing with a rectangle, so area equals length times width. The new area is 56. The new length is going to be the original length, which we're calling 4, plus the X that they're adding to it. And the new width is going to be the original width of 5, again, plus an x. So same thing being added to both of these. And now this is just a quadratic. I just have to FOIL this out, move everything over, and refactor it. So 56 can stay where it is. 4 times 5 is 20. We got 4 times x for 4x. X times 5 is 5x. And then x times x is x squared. Moving everything over and rearranging it to get it in standard form, I'm going to write the x squared first. And then 4x plus 5x gives me a 9x. And then finally 20 minus 56, that'll be a negative 36 for my last piece of this standard form. Now I'm going to look for factors of negative 36 that add up to positive 9. So we got 1 and 36, 2 and 18, 3 and 12. There's potential there. Negative 3, positive 12 would do it. So I'll write this as x minus 3 and x plus 12. Zeroing these out, I get x equals 3 and negative 12, but can't have a negative dimension. So I'm going to cross off the negative 12. I want to be kind of specific about why I'm crossing this off, though. It's not the fact that this is negative in itself, because there are negative numbers I could add to 4 and 5 that would give me still positive dimensions. It's the fact that this is a negative number that's less than that's less than 4 and 5. So if this were negative 2, I could actually work with that. I can't work with something that's going to make these two things negative, though. So 3 is the only answer there. And then we want the dimensions of the new garden. So we're going to have 3 plus 4, which is 7. And then 5 plus 3 is going to give us 8. So 7 and 8 are our new dimensions. And that is going to be in meters. So 7 and 8. 7 and 8. Where is that? Right here. Buys. There's what I put there. Here we go with problem G. This one is kind of similar to problem F in a lot of ways, but there is one key difference that is kind of a game changer. So dimensions of a rectangular garden are 3 by 10. Both dimensions are increased by equal amounts. The area, as a result, is doubled. We want the dimensions of the new garden. All right, so we can still use area equals length times width. And if I'm increasing these original dimensions by the same amount, I'm just adding the same variable to both of them, which I'll just use x because whatever. Instead of writing L, I can write 3 plus x or x plus 3, either way. And instead of writing W, I'll write 10 plus x. So now we also have to write something in for A. Now they said that the area of the garden is doubled. Well, what does that mean? It means we're going to do 2 times whatever the original area was. What was the original area? They didn't tell us. But they told us the original dimensions were 3 by 10. So 3 times 10 gives us an original area of 30. Doubling that gives me 60 for the new area. So this gives me everything I need to go ahead and solve the equation now. Let me multiply this out, move things over, refactor, and we'll go from there. So 3 times 10 is going to be 30. 3 times x is 3x. X times 10 is 10x. And then we have a plus x times x, or x squared. Still have 60 over on the other side. Now I'm going to get this all on one side and combine like terms. I'm going to write the x squared first because I'm trying to put this in standard form so I can easily factor it. 3x plus 10x gives me a plus 13x. And then 30 minus the 60 that I'm bringing over is a negative 30. And all of that now equals 0. Squared coefficient is 1, so I'm just looking for factors of negative 30 that add up to 13. 1 and 30? Nope. 2 and 15. Let me think about this. Negative 2 times positive 15 would give me negative 30, and then adding those would give me 13. So I'm going to have to write x minus 2 and x plus 15. Zeroing each of those out, I have x equals positive 2 and negative 15. And this negative 15, if I add that to 3 and or 10, that's going to give me negative dimensions. So because of that, I have to discard that answer. If I had something like negative 1, that would be okay because we'd still get positive dimensions, but not negative 15. So now I have to add 2 to each of my original dimensions in order to get the new dimensions. So that gives me a 5 and a 12. So 5 by 12, and that's going to be in meters for my units. 5 by 12, I see that toward the top here, so hot is the word there. So that's going in the box for G here, and we're on to the final problem. Here we go, last problem. We have a 4 by 6 meter rug covering half the floor area of a room, and this leaves a uniform strip of bare floor around the edges. So they gave us a little picture here. We want the dimensions of the room itself. So this is kind of like if I increase the dimensions of a rectangle into a new rectangle. I want to know the dimensions of the new rectangle kind of thing. So we'll use area equals length times width again. And this time around, we've got 6 plus x for the length of the new room. So 6 plus this x increase. And then the width of the room is going to be the 4 for the rug plus another x. Now, how about the area of the new room? Because we also need that in order to solve for x. Well, they said that a rug covers half the floor area of a room. So that means that the area of the room is going to be double the area of the rug. Since the area of the rug is 6 times 4, 24, that means the area of the room is going to be 2 times 24, which is 48. So there's my setup that I'm going to go ahead and solve now. Let me distribute this all out here. 6 times 4 is going to be 24. 6 times x, we have a plus 6x. X times 4 is a plus 4x. And x times x is x squared. Still have that 48 on the other side of the equation. I'm going to put this in standard form now. Let's see. Let's write the x squared first. And then 6x plus 4x is 10x. And then 24 minus the 48 there gives me a negative 24. All of that equaling 0. I'm looking for factors now of negative 24 that add up to 10. 1 and 24 doesn't work. How about 2 and 12? So if I did negative 2 and positive 12, that would add up to 10. So I've got x minus 2 and x plus 12. All that equals 0. Zeroing each of those out, we have a 2 and a negative 12. And if I add negative 12 to either 6 or 4, that's going to give me negative dimensions for the new room. And I mean, obviously, we wouldn't want x to be negative anyway, because the room presumably is larger than the rug. So we wouldn't be decreasing the area, we'd be increasing it. So we're going to cross out that negative 12. It just doesn't make any sense here. And then we're adding 2 to each of those dimensions. So 6 plus 2 and 4 plus 2 gives us the dimensions of the room itself. So that would be 8 by 6. 8 by 6, and that's going to be meters. So 8 by 6 meters, that's over here, 6 by 8, and that's water beds. All right, here we go. So now that I've filled in all of these boxes, I can go ahead and solve the puzzle, which was just, did you hear about? So the crooked furniture dealer who buys hot water beds. Well, that's interesting. How does this make any sense? So crooked means kind of criminal, and then hot in this context, when you're purchasing things, those could be like stolen water beds. So he's buying stolen water beds, but hot water beds sounds kind of comfortable. I wouldn't mind a hot water bed on some of those cold nights. So I think that's where they're driving at. It's kind of a play on words. Anyway, this is Mr. Sutton signing off.